Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Real Numbers. Here is the second week of annual academic calendar 2020 and 21, and this is the part 1 video. First of all, this is the cover page of the annual academic calendar released by APSCRT. According to this annual academic calendar, this is the syllabus for second week. If you observe this, you have to take up the chapter Real Numbers. In this, the work to be done or the concepts to be taught in the class are: the first is you have to learn the definition of logarithms, and we have to learn the importance of logarithms. And the next point is we have to learn the concept of how to change an exponential form to a logarithmic form and an equation in the logarithmic form into an exponential form. And the next concept is you have to learn the different laws of logarithms. We have to solve the questions from exercise 1.5 based on the concepts of logarithms and the laws of logarithms. These activities are to be done in the classroom in the second week. Besides the questions and solutions from exercise 1.5, the questions and solutions from exercise 1.4 are given as optional. But there are some important concepts in exercise 1.4, which includes we have to prove that root 2 and root 3 such numbers are irrational numbers using indirect method of proof. Therefore, in this video, we will learn how to prove root 2 and root 3 or 1 by root 5 or 2 plus root 3 such numbers as irrational numbers using indirect method of proof. Dear children, this is the chapter Real Numbers and this is exercise 1.4. And question number 1. Show that 1 by root 2 is an irrational number. Show that 1 by root 2 is an irrational number. Here is the solution. Here, let us prove this in an indirect method. That is, we will assume that the 1 by root 2 is not an irrational number. If 1 by root 2 is not an irrational number, then it should be a rational number. You see, let us assume that 1 by root 2 is not a rational number. If it is not an irrational number, then it is a rational number. This type of proving any statement is called indirect method. Here what we have considered, we considered that the given statement is false. Actually we have to show that 1 by root 2 is an irrational number. But in indirect proof, we took that the given question is wrong. That is, 1 by root 2 is not an irrational number. If 1 by root 2 is not irrational, then it should be a rational number. Since it is a rational number, you can write it in the form of P by Q. Since it is a rational number, 1 by root 2 is a rational number, you can write 1 by root 2 as P by Q, where P and Q are integers and Q is not equal to 0. So, you can write 1 by root 2 in the form of P by Q, so that 1 by root 2 is equal to P by Q. 1 by root 2 is P by Q, where P and Q are integers and Q is not equal to 0. Now, if you find the reciprocal of both LHS and RHS, you make it denominator as numerator and numerator as denominator, so that it is root 2 by 1 is equal to Q by P. Here, LHS is root 2. Root 2 by 1 is nothing but root 2. LHS is root 2. And we know that root 2 is an irrational number. And if you look at the RHS is Q by P. Since P by Q is rational, Q by P is also a rational number. Now if you observe this equation, LHS is an irrational number and RHS is a rational number. But we know that irrational number cannot be equal to a rational number. An irrational number cannot be equal to a rational number. Why? Because if a number is irrational, then it should not be rational. And if a number is rational, then it should not be an irrational. Therefore, an irrational number cannot be equal to a rational number, which is a contradiction, which is wrong. Then what is wrong? Our assumption is wrong, our assumption is false. Then what is our assumption? We assumed that 1 by root is not irrational. This is false. Therefore, 1 by root 2 is a rational number. Understood? This type of solving a mathematical statement is called an indirect method. In this indirect method, we took that the given question is wrong, and finally we arrived at a wrong conclusion. Therefore, our assumption should be false and the question is right. This type of proving a mathematical result is called indirect method. Look at the second bit now. Question number 1 and second bit. Show that root 3 plus root 5 is an irrational number. Show that root 3 plus root 5 is an irrational number. Here is the solution. We will prove this in indirect method. Indirect method means you have to assume that the given question is wrong. That is, let us assume that root 3 plus root 5 is not an irrational number. Well, actually, we have to prove that it is an irrational number. But since it is an indirect method, we will assume that the given question is wrong. That is, root 3 plus root 5 is not an irrational number. If root 3 plus root 5 is not an irrational number, then it is a rational number. Since it is a rational number, you can write it in the form of p by q. So you can write root 3 plus root 5 as equal to p by q, where p, q are integers and q is not equal to 0. Now, since you can find square roots, let us square on both sides. LHS whole square is equal to RHS whole square. Now LHS is in the form of a plus b whole square. What is the formula to find a plus b whole square? A square plus 2ab plus b square. That is, a square means root 3 whole square is 3 plus 2ab, 2 into root 3 into root 5, 2 into root 3 into root 5, plus b square means root 5 whole square is 5 is equal to p by whole square, ready, 1, 2, 3. P by q whole square is p square by q square. Now 3 plus 5 is 8 plus 2 root 3 into 5 is 15 is equal to p square by q square. Take this plus a to other side. Then 2 root 15 is equal to p square by q square minus 8. And root 15 is equal to, divide both sides with 2. Root 15 is equal to p square by 2q square minus 8 by 2. That is, root 15 is equal to p square by 2q square minus 8 by 2 is 4. Here, we know that p and q are integers. Then p square is an integer, 2q square is also an integer. Now integer by integer is a rational number. Minus 4 is always a rational number. Therefore, RHS is a rational number and LHS square root 15. 15 is not a perfect square, therefore root 15 is an irrational number. Now LHS is an irrational number and RHS is a rational number. Therefore, an irrational number cannot be equal to a rational number. Our assumption is false. What we assumed? We assumed that root 3 plus root 5 is not an irrational number, which is false. Therefore, root 3 plus root 5 is an irrational number. Now, question number 1, fourth bit now. Show that root 5 is an irrational number. I shall repeat. Show that root 5 is an irrational number. Here is the solution. Again, we will assume that the given question is wrong. That is, root 5 is not an irrational number. If it is not an irrational number, then it is a rational number. Since it is a rational number, you can write it in the form of p by q. So, you can write root 5 is equal to p by q, where p and q are integers and q not equal to 0. Now, by squaring on both sides, root 5 whole square is equal to p by q whole square. What is root 5 whole square? 5. P by q whole square means p square by q square. Now take this q square to other side. Then p square is equal to 5q square. P square is equal to 5q square. Since p square is 5 times of q square, then 5 can divide p square, because p square is in the form of 5 into something. The value of p square is in the form of 5 into something. Therefore, p square is divided by 5. 5 can divide p square. If 5 can divide p square, then 5 can also divide p. This is the first result. Now let p is equal to 5 times of r. How can I take this as 5 into r? Because 5 can divide p. Since 5 can divide P, P is in the form of 5 into something. P is a multiple of 5. Since P is a multiple of 5, P is equal to 5 times of R is some number. P is equal to 5R. By squaring on both sides, P square is equal to 5R whole square, that is 25R square. But we know that P square is equal to 5Q square. Therefore, 5Q square is equal to 25R square, or Q square is equal to 25 divided by 5 is 5R square. Q square is also in the form of 5 into something. Therefore, Q square can be divided by 5, or 5 can divide Q square and 5 can divide Q. This is the second result. Now, if you observe 1 and 2, 5 can divide P and 5 can also divide Q. From 1 and 2, 5 can divide both P and Q. What are P and Q actually? P and Q are numerator and denominator of this fraction. But while writing any fraction, this P and Q should be in the simplest form. You should write P and Q only in their simplest form. Therefore, our assumption is false. Why? Because 5 can divide both numerator and denominator. Therefore, it is not in the simplest form. Since the fraction is not in the simplest form, our assumption is false. Therefore, it is a contradiction. Since it is a contradiction, root 5 is an irrational number. Is it understood? Is it clear, students? You see here again, root 5 is equal to P by Q. You wrote root 5 value in the form of P by Q because we assumed that root 5 is not an irrational number and it is a rational number. Since root 5 is a rational number, you can write it in the form of P by Q. Here P and Q are integers and Q not equal to 0. And at the same time, if we write any fraction, numerator and denominator should be co-primes. Do you know what is meant by co-primes? Co-prime means they should not have common factor. They should not have a single common factor except one. Then only they are called co-primes. If you write P by Q as a fraction, P and Q should be in their simplest form. Simplest form means there should not be common factor. But here in this case, we arrived that 5 is a factor of P and 5 is a factor of Q. Since 5 is a common factor for P and Q, they are not in the simplest form or they are not co-primes. Therefore, our assumption is false. Since our assumption is false, root 5 is an irrational number. Is it clear now? Otherwise, you repeat the video again and verify so that you can understand properly. Here is fifth bit now. Show that 3 plus 2 root 5 is an irrational number. I shall repeat. Show that 3 plus 2 root 5 is an irrational number. Here is the solution. Let 3 plus 2 root 5 is not an irrational number. Since it is not an irrational number, it should be a rational number. Therefore, as it is a rational number, you can write it in the form of P by Q. You can write it in the form of P by Q, where P and Q are integers and Q not equal to 0. Now square on both sides. LHS whole square is equal to RHS whole square. LHS is in the form of A plus B whole square. A plus B whole square is equal to, we know the formula for A plus B whole square. A plus B whole square is equal to A square plus 2AB plus B square. Now you see, if you apply A plus B whole square to 3 plus 2 root 5 whole square, A value means 3 and B value means 2 root 5. A square means 3 square is 9 plus 2AB, 2 into 3 into 2 root 5, 2 into 3 into 2 root 5 plus B square is 2 root 5 whole square. 2 square is 4 and root 5 whole square is 5 is equal to P square by Q square. 9 plus 2 into 3, 6, 6 into 2, 12 root 5 plus 4, 5 is 20 is equal to P square by Q square. Now what is 9 plus 20? 29 plus 12 root 15 is equal to P square by Q square. And take this plus 29 to other side, then 12 root 15 is equal to P square by Q square minus 29. Or root 5 is equal to, divide with 12, p square by 12q square minus 29 by 12. Here LHS is root 5. Root 5 is an irrational number. If you look at the RHS, p is an integer and q is an integer. P square is an integer and q square is an integer. Therefore, p square by 12q square, it should be a rational number. Minus another rational number. Rational number minus rational number is always a rational number. Here LHS is an irrational number and RHS is a rational number. Therefore, an irrational number cannot be equal to a rational number. Since it is a contradiction, our assumption is false. Since our assumption is false, then 3 plus 2 root 5 is an irrational number. Is it clear now? Otherwise, you may play the video again and verify the concepts in which you are having doubts. And still you are having doubts, you may please post them in comment section and I shall reply. Thank you one and all.